Hi, Andrea here. Today we are going to talk about the connection between sets and logic. In the last few videos, we got the basic tools to work with sets. Nevertheless, we did not yet talk about the utility of sets in the context of logic. Let's think about propositions. Back to the car example, we talked about the possibility of deducing something from propositions referring to a car with fuel and without fuel. The aim here is to see this topic from another point of view, using sets. Let's consider two sets, whose elements represent different scenarios. We can imagine the first one contains every situation with no fuel in the car, and the second with all the cases in which the car is running. Just to fix the ideas, in the first set, one point can represent the case of the car with no fuel and two passengers on board, while a second point in the second set can be related to the situation of the car running with a broken mirror. Now, we want to know, given that the car has no fuel, if the car can work or not. We want to guess the right reasoning. This is the same than figuring out if two sets intersect, overlap, or if they are separated. But we know that the engine of the car cannot fire up without fuel. Therefore, the two sets have no intersection. This means that the two situations of the car with no fuel and the car running are impossible together. So we got our answer. This kind of reasoning can be also performed with numbers. Let's consider the following syllogism. Bn a number smaller than 3, Bn an even number, then n is 2. This can be proven using sets. In fact, if we draw the sets of the numbers smaller than 3 and the sets of even numbers, we have to check what is in their intersection, because we want a number that is smaller than 3 and even. The only possible element in the intersection is 2. Now we are starting to understand the power and the application of sets. We are finally ready to introduce numbers in a formal way and have fun with them in the next videos.